Hello everyone and welcome to this presentation. My name is David Halkai and I'm senior consultant here at Optiv Federal Canada, and I'm part of the TVMR team, Threat and Vulnerability Management and Remediation team. And let's start today our presentation about how we can use the AI decision-making techniques to help us as a consultant in our remediation planning and remediation operation. So let's take a quick look about what we're gonna do today. We're gonna provide the overview about the vulnerability management, a quick overview as well for vulnerability remediation and what are the challenges that we face usually for many clients. We're gonna also provide some introduction to the expert system. What are the expert systems and what are the use of the expert systems and how they can help, our field and a lot of fields actually. It's not just ours, like healthcare, banking, and a lot of application actually used nowadays for that. And the proposed expert system, I'm gonna provide a quick idea. We already started generating the the expert system itself, but we need some funds, so it's just about what inside the system and what are the main components about it and how this expert system works and what about, the pros and cons that we might face for the proposed expert system. So let's just start at the beginning for a quick introduction about vulnerability management. So what is vulnerability management? Vulnerability management is a process of identifying, evaluating, and remediation of the existing vulnerability. So if you have a company and you are in security team and working with vulnerability management, you're gonna find that you have a VM platform and you have some scanners, some agent installed in your internet and intranet to report the current vulnerability to the VM platform. So this implemented with other security tactics, in organization and how we can make some priority for the criticality of each vulnerability and how we can use them to minimize the attack surface. So the the vulnerability management started with discovery. So in this process, we discover the vulnerability, and this is done by the vulnerability management software in cloud or in-prem, it doesn't matter. And this VM connected with some scanners and some agent and grab the information about fingerprinting and some vulnerabilities already there for a software or open ports and something like that for the whole for the whole network and application as well. The next step is analyze, how we can analyze the findings. So we have tons of data now coming to VM platform. So how we can analyze those and use them to remediate the existing vulnerability. And also sometimes this connected with some risk intel and TI as well. So you can identify which vulnerability should be remedied first and what is the most critical vulnerability nowadays, and is there any exploit kit already available in the market, and the uh, the attacking, usability and something like that. The next process is respond, how we're gonna respond to that. And starting from this, respond and validating those two processes, the last two processes. So now we're gonna use our expert system. So our expert system focus on those main area, respond and validate. So in respond, how we gonna respond to the existing vulnerability? So how we gonna solve this? How we gonna fix some workaround or fix, you know, something like server hardening, or how we can patch those vulnerability based on the vulnerability and how we can remediate that. In this point, we need some information, from each client or each company, like SLA, like asset ownership and something like that. Then we're gonna fix them, as you can see here for patching, remediation, etc. The final step is validate, which means now we have patched and fixing everything. So now we need to validate if our remediation planning was good and everything has been remediated successfully, or we still have something. Okay, let's move to the next slide. Yeah, now we're gonna talk about the vulnerability remediation itself. So vulnerability remediation itself is a part of a vulnerability management. And in this, we usually starting with, how we're gonna identify the critical ones and what is the best CVS score. And is there other exploit kit already published for that? Is this vulnerability exploited publicly? So we can get some intel from many resources to identify what will be remediated in the first wave, for example. We also check the existing solution for that. So sometimes you find vulnerability that doesn't have patch so far. So what you gonna do for that? And the same thing for 0 day. So are we gonna disable the service, or we gonna just do some workaround or disable or close some ports and something like that. And after that, we try to make the asset prioritization. So we can say that we have internet facing assets and our intranet assets. So in this case, we're going to focus on what the attacker can see, what the attacker can deal with, which is, for example, internet-facing assets, internet-facing web server, database server, or whatever. In this case, we give a priority to those assets, and we start focusing remediate those first. Sometimes also the next step is to open the tickets. In this case, now you have the plan. This is our first wave of remediation. So let's go and open some tickets for that. And the solution itself, so in that ticket as well, the mitigation will be in. So the resources has to fix that based on the proposed solution, and finally validate the mitigation and make sure that the vulnerability already fixed, so we can run ad hoc scan, or we can wait until next scan to see if there's vulnerability already fixed or not. And at the same time, we have to update the current remediation plan to reflect the new changes. So it's a long process and takes some time, you know, to generate just the plan based on many criteria like the client SLA, how many resources they have, do they have patching team, onshore, offshore, and sometimes we need someone from the admin team to fix this vulnerability, someone from OT team to fix this vulnerability. So it's a long process. So yeah, we we face a lot of challenges with remediation planning. The first and most important one is not fixing the vulnerability, no remediation. I've been working in this field in vulnerability management as a consultant for 8 years now, and I can tell 95% of many customers in different fields, they have a problem in that related to many other criteria like lack of resources, like this patch may need doing some restarting. And when we're gonna fix that, off hours or weekend or something like that. But finally, we see a lot of vulnerabilities that already reported but not fixed. So, uh, let's go for the 84%. Yeah, this is some statistics here. About 84% of companies with a high risk vulnerability in their network, and just one of 10 of those vulnerability has publicly available exploit. So in this case, till now in 2023, we still found WannaCry. Can you imagine? We still found Log4j in many companies, in many resources. So, and also 50% of the remain vulnerabilities are unpatched, within the last 6 months. And about 80% of the attacks in 2020, based on the cybersecurity report, involved the vulnerability reported in 2017. So this is what I was talking about for the first challenges we face for remediation. And we found that the most important cause is there is no remediation reliable plan. So they don't have a good plan, so the assigned source can do the right job, and at the same time, the vulnerability increased every day. So they don't fix the previous one, and now they have a new one, and they got stuck. What to do first? And going in the same loop. So this is the many challenges actually, and this is take a lot of time. So we provide this service in our department here, and we found a lot of our clients, having the same problem with remediation planning. So it takes time. So now let's talk about what is the expert system. So expert system, we can say it is a subdomain of AI. Usually this is used as a rule-based machine learning, which is supervised machine learning, and some knowledge base, okay, just to provide the best solution for a problem. So in our case, now we have a problem with remediation planning. So what we're gonna do for that? We're gonna let the proposed expert system decide what is the best plan for that client based on its SLA, current resources, the existing vulnerabilities, the asset criticality, and a lot of other criteria. So normally, expert system is simulate a behavior of judgment of a human, okay, especially in consulting industry. It gets a relevant knowledge from its knowledge base and translate that to a user problem. So the expert system usually solves the real world problem and emulates a human expert, and it's able to save time and cost, I can say, over 60%. And the machine learning itself will learn by experience. So with time, there is no need to spend 100% as a consultant time doing that. So my system will do that. So what are the general usage of the expert system? Now we have a lot of application for expert system in advising, in medical diagnosis, in enhancing the sales and marketing. A lot of application already published for the expert system. So let's talk a little bit about what are the main components of the expert system. Expert system usually consists of five components: knowledge base, and the search or user interface, and inference engine, and from the back end, there is a knowledge acquisition module, which is now I'm a consultant as expert. I'm gonna feed some information, not data. Forget about data now. I'm feeding some information to the knowledge base. So, for example, if you have one, two, three, please do that. If you have two, three, and one, please go and do this first and come back and do that, and something like that. So we can say that the user, okay, in our case, we can say our client send a query to interface saying, okay, Mr. System, could you please give me the best remediation vulnerability remediation plan in the next, we can say 15 days based on our situation, and here is our resources, here is our service level agreement, and so on. So the system will consult its knowledge base and doing some functions and finally provide the the best answer. Uh, Now we're gonna talk about the proposed expert system. This is I just want to confirm that we just started the blueprint of that. We, we I'm not sure if Optiv will do that or another company will fund that. I'm not yet sure, but let's talk about the idea itself. So the knowledge base here is, you can say, it's represents something that includes knowledge. Knowledge base, it's something like database, but instead of data, it includes information, expertise. The inference engine, this one is getting the relevant data from knowledge base, translate it, and find the solution. Okay, for the GUI interface, in our case, it will be SaaS interface. So any consultant with subscription can go there and go to his workspace and do whatever he wants. The explanation module, which is a part of inference engine, which means in the inference engine, you're gonna decide what to do. But explanation module is how this decision was uh, taken. Okay, what are the main criteria used for that? What are other components? Let me, as a system, took that decision. And in our case as well, in our proposed system, we're gonna use supervised machine learning, and we're gonna use both of them. And this is a little bit strange or new, because in our case, we're gonna use both of them. deep machine learning, and the rule-based learning. And we're going to talk about this in next couple of slides. At the same time, the proposed expert system, we believe if this will be implemented, we're going to use around 80 to 20 rate just to train and test the system. Yeah, here the learning is the most important part of our expert system. In this case, as I mentioned before, we're going to use a combination of rule-based and self-learning system. Okay, until not forever. Rule-based learning will be used until our machine learning is able to match our expected decision. So when we find that the error rate between 1 to 2%, so at this point we can stop the rule-based machine learning and use just the self-machine learning. So machine learning will go in the past, see what decision has been taken for the same problem or new problem and learn itself. For the rule-based model, it's a very simple. If you think about it, in a small statement, it's just if and then, okay? And you can say if yeah, if the yeah, you can say something like please provide me a solution if you have. Exploit is true. Vulnerability time, sorry, vulnerability type is remote attack, and CBS score over 9 or 10%. The architecture of our proposed expert system is very simple. Here is a VM member who has a subscription to our SaaS EX system and send a query as what is the best remediation plan for my current situation in the next month. And this query is sent to inference engine, which goes to interact with the knowledge base to transfer the input and uh, transfer the inputs and get some information, okay, about the proposed plans for that. And finally, explanation subsystem give us everything about why this decision, in our case, this plan has been chosen based on what. So it is very simple concept, but at the same time, it needs a lot of work. And this is one cons of the expert system or any AI in general. So how this system will work? So this system imports the client vulnerability finding from the API, then ask our clients for some question like current state analysis, like SLA, IT resources tool you're using. Then the system will analyze and consult the data and answer, then provide the answer and start building scenarios. In our case, our expert system will generate 3 scenarios, which mean 3 plans, okay? Then choose the best one, because if the user doesn't like the first one, he will choose the other one and so on, but maximum 3. So yeah, if the client is satisfied with the best decision, so the system will continue to the next step, but if not, the second plan will be the solution. Then the expert system, after that, will open the required ticket automatically in that client platform, okay, and assign at the right resource based on process 1 and 2. And the system also will, one more thing. This system connected to many TI, threat intelligence resources, so he get the last solution for that. It doesn't depend on a VM platform and solutions they provide, but it depends on what is the root cause of that problem and what is the best solution. So it gives the solution as well, the best solution, and the system is able also to install the available patches automatically with, via some third-party tools already integrated with the system, and system after that will track the plan progress and compare it with what remediation has been done and update itself, daily or weekly basis. The system again will predict if our mitigation plan will be completed on time or there is some delay. So it updated itself based on the current changes, and at the same time, the expert system will look for the new finding on daily basis to update the plan based on what what the system will find in on daily basis. Then finally, the expert system will provide some weekly report to VM team and IT manager to let them know this is where we are, this is the remediation plan, this is what we have done, is missing, and the system updates the plan itself. Here is a quick look about, the concept map of the knowledge base, assets, vulnerability, SLA, mitigation, a lot of, a lot of a lot of components here, as you can see. And yeah, let's talk very quickly about the pros and cons for this one. It's easy to adapt, okay, and provide reasonable explanation and decision for remediation plan, dealing with uncertainty 100%, adaptive learning, reduce the consulting time and cost more than 70%. And this is the most interesting part, which is you're gonna reduce your consulting cost by 70%. So instead of they working in one project, they're gonna work with 5 to 6 other projects and using the same system for a specific area. But we have a problem here in cons. The first one is funding. Those type of system takes a lot of money. So I'm not sure yet what's gonna happen about that, but yeah, one of the most one yeah uh, one of disadvantage of the expert system or AI in general is funding and difficulty also in creating the inference rules. It takes time because you are dealing with human at the beginning, and other cons, and but the most important one is cost. So I think I'm done, and I'm happy to hear any question. Thank you, and I hope you join this slide. Thank you.